Hey guys, in this video we're going to talk about Leetcode 523, and this question can also be asked in Facebook interviews. So for this problem, we're going to be given an integer array and an integer k, and then we return true if the array has a good subarray. So a good subarray, the subarray where the length is at least 2, and also the sum of all the elements in the subarray is a multiple of k. So for most of the case, when we are dealing with sum of elements in the subarray, we have to use the algorithm of running sum. So what it does is like we just loop over the array and keep track of all the elements, the sum of all the elements from the index 0 to the current index, and then store the value in the map with key as the sum and the value as the current index. So let's go through an example. Let's say if the input array is like 2, 3, 3, 2, then what we need to do is like we just loop through the array, and then the current sum would be, if we on the first element, the current sum will be 2, and then we map 2 to index 0. So the key will be the sum, and the value will be the index. And if we loop to the second array, the total sum will be 5, and then we map it to 1. And then we loop to the third element, it will be 8, and map it to 2. And then loop it to the end of the array, then we have like 10 mapped to 3. So with this, so as we loop through the elements in the array, we can know the sum, the current sum of all the subarrays. So for example, if we're at index 2, right? And then the total sum from index 0 to index 2 is 8. And if we need to have if we need a subarray of sum maybe 6, then we can just say 8 minus 6 will be 2. So let's check if 2 is in the map or not. And it is in the map. So we can know from index 0 to index 2, excluding index 0, and then we can have a subarray of sum 6, which is index 1 to index 2. So this is a subarray of sum 6. So how do we apply this algorithm to this problem? So let's go through the first example. So we loop through the elements in the array. So that's and keep a running of the total elements running of the sum of the elements here. So what we can do is like we are on the first element, right? And it's 23. So instead of store 23 into the map, we just store the 23 divided by 6 and store the remainder in the map, so that we can know like it will be like 5 and it will map to 0. So in the future, if we have another array running sum which has a remainder of 5, then we can know starting from index 0 to the current index, we're going to have a sum which can be divided by 6, excluding index 0. So now we loop to the second element in the array, which we're going to get 25, and 25 divided by 6 will remaining 1. So 1 is index 1. And then we to the third one, which is 4. So the sum of these is 29. 29 divided by 6 will be 5 minus, well, remainder is 5, right? So, and then we will check if we want to get a subarray of sums divided by 6, then we need to have 5 in the array, in the map as well. So we already see a 5 in the map. And now we see another 5, right? So which means like index from index 1 to 2, we can have a subarray which can be divided by 6. So basically, this is how we apply running sum algorithm to this problem. So let's try to code it out. All right. So we first need to have a map which can map the remainder of the map the running sum of all the elements from the index 0 to current index, and then we store the remainder of the sum divided by k. So let's say let's just name it running sum map, okay? And then have it in dictionary, make it a dictionary. And then we need to keep track of the current sum. And initialize it to 0. So now we need to iterate through the array. So for index and the num in enumerate, just look through the array. So current sum would equal to plus num, and then the key of the dictionary, so remainder would be sum divided by k. So now if remainder is not in the map, it's not there, then just save it and map it to the current index. Map this remainder to the current index equal to index. Otherwise, if it's already there, then we need to check, because we need the length of the subarray at least 2, right? Else, if current index, so previous index would be this. If index minus previous index is larger than, so if it's 0 larger than 1, so that we can have maximum 2. If 0 and then 2, larger than 1, so we return true. And if none of them, if we iterate through the entire array and none of them return true, then we just return false by default. Right, and let's see how it goes. Okay, so there is something failed. Let's see. Key equals 7, expected true. Let's see. So test case, k is 7. Oh, I think I know why, because I need to initialize the map. So the running sum is always 0. The sum is always 0 when it's at index 0, right? So the sum at index, so so we need to just initialize the running map. So it's at index 0, the sum is always 0. Yeah, because in this case, I think 23 plus 2 plus 4 is 25, 29, 25, 29, 29 plus 6, 35. 35 is divided by 7. Yep. So I think we just initialize it here. Let's see how it goes now. Okay, so another failed case. Let's see. Wrong answer. 2, 6, 2, 4. Oh, so if it's 0, then it will be inclusive. So let me just make it -1. Yeah. So this index will be exclusive on both sides. Yep. All right. So yeah, so because I make it -1 because in the running map, right? So the sum will be the previous, like the map to the index, but when we calculate the length, it will be exclusive on this index. So that's why I make it -1 instead of 0. So the time complexity and the space complexity both of them will be order of n, because we have a running map, and then we look through the array one time. All right, this is the end of the video, and I'll see you guys in the next question.